Hello friends, I'm here with one more simulator. This was created by SpaceX and NASA together, and this simulator will familiarize you with the controls of actual interface used by NASA astronauts to manually pilot the SpaceX Dragon 2 vehicle to the International Space Station. So this simulator helps you understand the complex and precision driven phenomena of docking. So we can't dock the Dragon vehicle towards the International Space Station at any other point except the docking area, and we can't do it at a high speed or high rate because if the push is too hard, it may crash onto the International Space Station. So uh, this is the interface which we are going to use. There are three concentric circles as visible on the screen. So the central dot, which is at the smaller which is present inside the smaller circle, has to be aligned with the dot at the docking point in the simulator. Uh, this is the same interface which uh, is a touch screen, which is on the touchscreen platform and which is used by NASA astronauts Bob and Doug Bob and Doug um, to dock the Dragon vehicle to the International Space Station. Now these are the buttons which I'll show you during the simulation. These are the buttons, and there will be hexagon shaped shapes through which we need to push the Dragon vehicle towards the docking point. Remember, the docking has to be very slow and steady. It's a head-up display, that is the rolling angle, the pitching angle, the amount of roll, the amount of pitch will all be on screen in front of the eyes of the astronauts. So let us begin. Quite good graphics in the beginning, and this is the space station, and we are right now sitting inside the Dragon uh, vehicle, and the Dragon vehicle is around 202 meters away from the docking point. That is um, that is shown on the that is shown inside the circle. That is uh, there are different elements which are given on the inside the circle, That is the roll angle, the pitch angle, the rate at which the vehicle is moving. That is this one. Can you see the rate is increasing now? So it is moving at a rate of uh, minus 52 meters per second. Minus means we are moving towards the um, space station, and plus means we are moving away from the space station. Okay, so if the rate is positive, we are moving away from the space station, and if the rate is negative means we are going towards the space station. And now ironically speaking, if you press plus, it would rather show a negative 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 value, and if we press minus, it will show positive value. Okay, now this button is for rolling in the anti-clockwise direction. This button is for rolling in the clockwise direction. This is for yawing towards left side. This is for yawing towards right side. This is for pitching up the vehicle, and this is for pitching down. And this will translate the vehicle up, this will translate it down, this will translate it right, and this will translate it left. So that's how you have to maintain the uh, vehicle to, and the green dot that you see has to be maintained and aligned with the central point of the concentric circle. The interior point, the center of the concentric circles, has to be maintained aligned with the center of the square, green color square, which you see on your screen now. Okay, and now on the top right of your screen you can see a gyroscope. At all times the light blue part of the gyroscope should be up and the dark blue or black part should be down. That is in layman's language to maintain a steady movement towards the space station. This is the touch screen that the astronauts are using to dock the vehicle to the space station. The interface will be on the touch screen as shown in the simulator. So the link for the simulator is in the description. You can click on the description and it will take you directly to the simulator game. Thank you.
Okay, here you can see the Dragon vehicle coming up underneath the space station. This is about a kilometer below ISS. It performs a series of maneuvers to fly radially around to what we call the V-bar. This is the velocity vector that the ISS is traveling in, and that will align it up on the docking axis aligned with the docking port. This video is extremely sped up, so it shows things in a much higher speed, but the graphic itself is taken from one of the training and simulation runs that we did as a joint NASA and SpaceX team practicing this rendezvous event. As Dragon approaches the V-bar here, it'll be about 220 meters away from ISS. You can see in the multiple camera views what one camera will be seeing as it looks towards ISS out of the center of the docking mechanism. At this point, the crew is going to take manual control and do a manual flight test. This will be a capability that we're demonstrating should there ever be in the future a failure of the docking mechanisms, of the rendezvous mechanisms. We're able to manually pilot in the Dragon spacecraft towards the ISS and complete the docking manually. Here, the crew will be demonstrating a series of translations and maneuvers in the Y and Z axis as they really get some stick time flying the vehicle manually versus the computer automated control. As that test completes, the crew will then pause the vehicle, put it into a hold state. The flight control team will then be able to transition Dragon back into an automated approach sequence, and it will begin to resume its rendezvous towards ISS once again. As Dragon approaches ISS at about the 20-meter point, there's a built-in hold where we do our final go, no-go checks to make sure we're ready for the final docking. You can see the Dragon here holding at about 20 meters. At that point, we proceed from that hold point for the final docking sequence after that go, no-go verification has been given. At this point, this is all again under automated docking sequence. There's a series of navigation sensors that control Dragon to keep it perfectly aligned with the docking mechanism. And then we have the final contact and soft capture.
Launch trajectory countdown now. Pad is cleared. Go for launch.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Ignition, liftoff.
Separation confirmed. MVAC ignition. Dragon, separation confirmed. Separation visually confirmed. Mains have been deployed.